Hello, this is Olivia Luchetti, and today I will be talking about how complex numbers are used outside of the math classroom and in the real world. So, right now you're probably asking yourself, what exactly is a complex number? Also known as an imaginary number, a complex number expresses a quantity in the form a plus bi. A and b are real numbers, while I is imaginary or complex. Before, you may have been taught that it was impossible to take the square root of a negative number, but now I allows you to do so. I equals the square root of -1. So when simplifying the square root of a negative number, you can pull out I along with any other factors that are perfect squares. Moving into applications. The use of complex numbers in professions is very intricate. The professions that require this skill are viewed as extremely difficult, like electrical engineering. This job uses complex numbers, most commonly dealing with alternating current or AC circuits. These circuits deliver electric power to businesses and homes in a wave. The voltage, impedance, and current of these circuits are all multidimensional because they alternate in frequency and phase shift. Because of this multidimensional characteristic, complex numbers are used. Complex numbers make expressing all of these factors easier. Electrical engineers use the equation E equals I times Z, where E equals voltage, I equals current, and Z equals impedance or resistance. The answer is given in complex form using ohms as a unit. Now let's move on into our second application, quantum mechanics and physics. Quantum mechanics states that subatomic particles like electrons and smaller particles like photons can either behave like waves or in their particle shape. If behave like particles, their probable location can be pinpointed using this technique. The intensity and phase of these are represented by two real numbers. Complex numbers are used to write these two numbers in shorter forms. It would be possible but very difficult to express the wave and particle relationship with real numbers. The imaginary component shows phase, either in phase, with waves that are in sync, or out of phase, which are out of sync. So, just to give you an example of each type of wave, the first wave shown is an in phase, the second wave is shown that is out of phase, and the third wave that is shown is extremely out of phase. So, in conclusion, imaginary or complex numbers make the lives of the scientists and mathematicians who use them easier. Complex numbers make field work less difficult by representing two real numbers as one imaginary number.